Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Troubleshooting Compute Resources. Troubleshooting compute resources is an essential skill for any IT professional, particularly those pursuing the CompTIA Cloud Plus certification. As cloud environments become increasingly complex, the ability to quickly and effectively diagnose and resolve issues with compute resources is crucial for maintaining operational efficiency and ensuring high availability. Compute resources encompass virtual machines, containers, serverless functions, and the underlying hardware and hypervisors that support these entities. Each of these components can present unique challenges, and effective troubleshooting requires a comprehensive understanding of the entire ecosystem. Virtual machines are a fundamental component of cloud computing. When troubleshooting VMs, it is essential to consider both the guest operating system and the hypervisor. Common issues include resource contention, configuration errors, and network connectivity problems. Resource contention occurs when multiple VMs compete for limited resources, such as CPU, memory, or storage. Monitoring tools like VMware's vRealize operations or Azure Monitor can help identify resource bottlenecks and guide remediation efforts. For example, vRealize operations can provide insights into CPU ready times, which indicate how long VMs are waiting for CPU resources. High CPU ready times suggest that the host is overcommitted and may require rebalancing workloads or adding additional compute resources. Configuration errors can also impact VM performance and availability. Ensuring that VMs are properly configured with the appropriate resource allocations, network settings, and storage options is critical. Misconfigured VMs can lead to issues such as boot failures, application crashes, or degraded performance. Tools like Microsoft's Azure Resource Manager templates can help automate and standardize VM configurations, reducing the likelihood of human error. Network connectivity problems are another common issue when troubleshooting VMs. These problems can arise from misconfigured network interfaces, incorrect security group rules, or issues with the underlying network infrastructure. Network diagnostic tools, such as traceroute, ping, and network performance monitors, can help identify and resolve connectivity issues. For instance, if a VM cannot communicate with an external service, a traceroute can help pinpoint where the connection is failing, whether it is at the VM's network interface, the virtual switch, or an external router. Containers, which have gained popularity for their lightweight and portable nature, present their own set of troubleshooting challenges. Containers are often deployed in clusters managed by orchestration platforms like Kubernetes, which adds an additional layer of complexity. Common issues with containers include resource limits, image pull errors, and inter-container communication problems. Resource limits can be set at the container level to prevent any single container from consuming excessive resources. However, setting these limits too low can lead to performance degradation or application failures. Monitoring tools like Prometheus and Grafana can provide real-time metrics on container resource usage, helping to fine-tune resource limits. Image pull errors occur when a container runtime, such as Docker, is unable to retrieve the required image from a registry. This can be due to network issues, authentication problems, or the unavailability of the image. Ensuring that the container registry is accessible and that appropriate credentials are provided can help resolve these issues. Additionally, using local image caching can reduce the dependency on external registries and improve deployment reliability. Inter-container communication problems can arise from network policies, service configurations, or DNS resolution issues within the cluster. Kubernetes provides several tools for diagnosing these problems, such as the kubectl command line tool and network policy analyzers. For example, if a containerized application cannot reach its database, kubectl logs can be used to examine the application's logs for error messages. while kubectl describe can provide details on the network policies and service endpoints involved. Serverless functions, which abstract away infrastructure management, can simplify development and deployment, but also introduce unique troubleshooting challenges. Common issues with serverless functions include cold start latency, execution timeouts, and dependency management problems. Cold start latency occurs when a function is invoked after a period of inactivity, requiring the platform to provision resources and initialize the function, leading to increased response times. Monitoring and optimizing function invocations, such as by keeping a minimal baseline of warm instances, can mitigate cold start latency. Execution timeouts can occur if a function exceeds its allocated execution time, often due to inefficient code or unexpected delays in external services. Profiling tools and performance monitoring can help identify bottlenecks in the function's code and optimize execution times. Dependency management problems can arise when functions rely on external libraries or services that are not available or properly configured. Ensuring that all dependencies are included in the function's deployment package and that external services are accessible can help resolve these issues. The underlying hardware and hypervisors supporting compute resources also require attention during troubleshooting. Hardware failures, such as disk crashes, memory errors, or network interface failures, can impact the availability and performance of compute resources. Monitoring tools like Dell EMC Open Manage or HP System Insight Manager can provide real-time alerts on hardware health, enabling proactive maintenance and quick resolution of hardware issues. Hypervisors, which manage the virtualization of hardware resources, can also introduce challenges. Issues such as hypervisor crashes, resource contention, or misconfigurations can impact the performance and availability of VMs. Monitoring tools, such as VMware's ESXi or Microsoft Hyper-V Manager, can provide insights into hypervisor performance and help identify resource bottlenecks or configuration issues. For example, if a hypervisor is experiencing high CPU usage, it may indicate that the host is overcommitted and additional compute resources may be needed. When troubleshooting compute resources, it is essential to adopt a systematic approach. This involves identifying the symptoms, gathering relevant data, analyzing potential causes, and implementing corrective actions. For example, if a VM is experiencing slow performance, the first step is to identify the symptoms, such as high CPU usage or disk I/O latency. Next, relevant data should be gathered, such as performance metrics, system logs, and configuration settings. Analyzing this data can help identify potential causes, such as resource contention, misconfigured settings, or hardware failures. Finally, corrective actions, such as rebalancing workloads, optimizing configurations, or replacing faulty hardware, can be implemented to resolve the issue. In summary, troubleshooting compute resources is a critical skill for IT professionals, particularly those pursuing the CompTIA Cloud Plus certification. Effective troubleshooting requires a comprehensive understanding of the entire compute resource ecosystem, including virtual machines, containers, serverless functions, and the underlying hardware and hypervisors. Common issues, such as resource contention, configuration errors, network connectivity problems, and hardware failures, must be systematically identified, analyzed, and resolved. Utilizing monitoring tools, diagnostic utilities, and best practices can help ensure the efficient and reliable operation of compute resources in cloud environments. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.